जय गौ माता, जय गोविंदा, जय गोपाला। कैसे हैं आप सभी अच्छे होंगे। एंड नाउ लेट अस कम टू गैया वाले गुरुजी की फिजिक्स की क्लास। एंड टुडे व्हाट वी आर गोइंग टू डिस्कस इज कूलम्ब्स लॉ। सो I have already told you in the previous class that how exactly the charge is originated. So I have given you a glimpse of charge, its origin, and of course its cause, and also I have given you a brief introduction of um, quantization of charge, and of course the fundamental charge. And I also went through the law of conservation of charge. And my dear students, you may belong to the class 9th, 10th, 11th or 12th, whatsoever it may be, or you may be in a state of preparation for some other competitive examinations. These things, the charge, its origin, its cause, quantization of charge, fundamental charge, and the law of conservation of charge. This is included in each and every class, and also it is related to competitive examinations. Today we'll move little ahead of this. And today's topic, as I have already told you, जैसा मैंने आपको बताया है कि हम बात करेंगे कूलाम के नियम की। कूलाम्स लॉ। बट बिफोर दैट थोड़ा सा इधर देखते हैं। चार्ज ऑफ कोर्स the atom is electrically neutral. Basically it does not have any charge because in the nucleus we have got protons having positive charge, and around the nucleus in closed orbits we have got electrons which have got the equal and opposite charge, so they balance each other and the net charge is zero. But when how exactly is the origin? The origin is because of the imbalance of protons and electrons. If the electrons are added to the atom or they are taken out of the atom, then this balance gets disturbed. और इसके बाद जो भी पदार्थ है जिसके साथ ऐसा होता है, the material which loses electron gets positively charged, and the material which gains electron it gets negative charge. Quantization of charge. So charge cannot be produced in any amount. No, it is because of the transfer of electrons. So the net charge on one electron is called fundamental charge. This is 1.6 into 10 raised to the power minus 19 coulomb. Coulomb, of course, is the unit of charge, and it is the name of the scientist also. So on any material, the amount of charge is a multiple of fundamental charge. It may be 1e, it may be 2e, it may be 3e, it may be 4e, it may be ne. And the law of conservation of charge, that is, in any charging process, the net charge produced is zero. That means in any charging process, we get equal and opposite charges. If we are rubbing two objects, one object is getting plus q charge, then another is going to get minus q, the total remains zero. So now let us come to the Coulomb's law. If we have got object A and of course object B, and they are placed at a distance of r, it has got charge Q1 and it has got charge Q2. So they are going to experience some force. Let me tell you, if they are of same nature, they are going to repel each other. If they are of opposite nature, they are going to attract. So that means if it is plus, they are going to repel. That means force of repulsion. Even they are like this. So in both the conditions, they are going to have the force of repulsion. प्रतिकर्षण होगा यदि एक जैसे आवेश है तो ये जो बल है दोनों के बीच में लगने वाला है ये प्रतिकर्षण बल होने वाला है. बट इफ एक प्लस है दूसरा माइनस है और एक माइनस है दूसरा प्लस है तो ऐसी परिस्थितियों में it is going to have force of attraction. अगर कोई चार्ज नहीं है दो ऑब्जेक्ट के बीच में, if there is no charge on any one of the objects or anyone, then this Coulomb's law does not hold. That means the force, electrostatic force becomes zero. So now let us see. What does this Coulomb's law say? The force is proportional to Q1, Q2. This is relation number 1. So that means more is the product of the charge on two objects. More is going to experience force of attraction or force of repulsion. Less is the product of these two. यदि Q1, Q2 का गुणनफल कम है तो यहाँ जो आकर्षण या प्रतिकर्षण जो भी बल लग रहा है कूलम का बल वो कम होने वाला है. ये ज़्यादा है तो ज़्यादा है. इनके बीच का अगर जो डिस्टेंस है, दिस इज r इज द डिस्टेंस, सो दिस इज 1/r². सो दैट मीन्स दिस रिलेशन स्टैंड्स फॉर द रिलेशन बिटवीन द फोर्स एंड द डिस्टेंस बिटवीन द टू चार्जेस. सो यहाँ अगर दोनों के बीच में दूरी r है तो उसके वर्ग के व्युत्क्रमानुपाती यहाँ फोर्स लगने वाला है. नाउ लेट अस गिव सम डिटेल्स अबाउट दिस. अगर यहाँ r को आप दोगुना करेंगे तो यहाँ जो फोर्स होगा 1/2 का स्क्वायर मीन्स 1/4 रह जाएगा. इट इज गोइंग टू बी 1/4, दैट इज 1/2 स्क्वायर. अगर इसको आप 3 गुना करेंगे जो फोर्स है वो 1/3 का स्क्वायर मीन्स 1/9 रह जाएगा. अगर आप 4 गुना करेंगे दिस इज गोइंग टू बी 1/16. सो प्रोडक्ट जितना ज़्यादा होगा फोर्स उतना ज़्यादा होगा, लेकिन डिस्टेंस जितना ज़्यादा होगा फोर्स उतना ही कम होगा. अगर इन दोनों रिलेशंस को लेते हैं फ्रॉम रिलेशन 1 and 2, I am not calling this equation. These are relations. There is no sign which is equal. So equation is only when there is an equal sign. It is simply giving you information about how exactly force